Hey everybody, very happy to see you all on Saturday weekend evening. Uh, I'm very glad to be back at my home city talking about Flutter for the first time. So today we'll see how to integrate TensorFlow into our Flutter application as a AI features. And short description about myself. I'm Akshay. I stay at Bangalore. I'm a freelance Flutter dev, and I'm also a tech lead at a company, Sadhana BM Pvt. And I have got a couple of opportunities, to represent and talk about Flutter at various conferences, DevFest, Flutter Forward Extended, and just a fun fact, for others it's a Valentine February, but for me this is a Flutter February. So continuously since past 4 weekend, I'm kind of traveling and sharing my knowledge on Flutter. So feels great. So if you if you have any questions or if you want to talk about Flutter, feel free to scan the QR code. Also, we can network after the talk. So let's see what's an agenda for today. It is very simple. We'll see why AI assisted features are rapidly growing with mobile applications and how our AI is being used in our real life. And from a developer perspective, let's see how deep learning works. That is, in this talk, I will not only talk about integrating a package to Flutter with a model which is already been developed, but we'll see some ways how we can train the model. As a mobile developer, we need to understand that in order to develop a bug-free AI feature with Flutter app. And we'll see how Flutter TFLite to be integrated with Flutter project, and we'll see a demo. So that's it for today. So our life has rapidly started revolving around AI. It's not human first at a mundane task what we do in our day-to-day life. It is AI because we are replacing all the manual tasks with AI. Even with the latest about ChatGPT, how it quickly brought a very trendy change in the market, and Bing is everywhere now. We used to mock Bing, Microsoft Edge, but now developers are adopting it. And also, from fun to e-commerce recommendations. And also, in lockdown, if you have seen on Instagram, Facebook, many used to mock saying virtual girlfriend, you don't have a girlfriend, you have multiple girlfriend, blah, blah, blah. From fun to the serious use case, AI is used at a under hood. So let us see. For example, my friend suddenly created a fake account, and he used the Facify app. And this is not my friend, but something similar I got on Chrome. So and he started flirting with many of our class boys, and few actually fell for it, and they became bakra. And a very fun use case, but again AI, Snapchat filters. And this is one of the similar feature. I can say that since lockdown, everybody are facing mental breakdowns. They are facing they are facing a lot of mental anxiety sitting at home. But at that time, due to the situations, we can't meet in person. At that time, more than thousands of applications were launched on Play Store, where it used to detect the mood based on text or virtually interacting with the app, and it used to suggest something like you need to watch some movie or do yoga, something. And eventually these became a passive income generating ideas. We wouldn't have even thought that this would fetch us some dollars, but developers who started it as a fun project are now earning in $1,000, etc. And this is also a e-commerce perspective when it comes to a retail use case, and that is Snapchat. We can ignore that. We need to just have an initial search, and based on our selections, automatically we know that our data is getting tracked regardless of hundreds of privacy policies. But AI is working in order to suggest us the best costumes or daily outfits. And to the serious use case where before we used to finish the deal of the fine from 1,000 to 100 by bribing the police, but now it can't happen, at least in Bangalore, because cameras are installed everywhere, and with the photos we get a post to send to our room. So we saw a lot of use case from a basic childish use case to a serious use case which is used by government nowadays. But how to develop AI assisted feature in mobile application? So let's explore in today's session. And firstly, let us use a divide and conquer approach where we'll try to, even when I started understanding deep learning or how to integrate AI, seeing fascinated on Twitter, it was too much at once. Like we have to collect the data sets and there are image based, text based, so much. But let us break it down and we'll take a single use case and we'll try to see how to do it with Flutter application. So we can divide our AI models in two categories. One is text based and image based. In image based, this could be as simple as facial recognition, what we have a biometric face lock, etc. And we can track the object, what now the toll plazas are tracking. And when it comes to text based, we all know that we'll be seeing many people will be tagging Zomato, Swiggy, complaining about their order, wrong order, etc. And depending upon the tone, the bot will automatically reply. If it is good, then it will ask the user to rate on the App Store or Play Store. If it is bad, it will ask about the tracking ID or order ID so that they can deal the issue and they can bring the justice to the user if they have severely faced any issues. So that is on the text based. So but what is this AI model? So let us see, if we take a simple example, right? So we have an input that could be any image. It could be car, it could be our face, it could be a watch, etc. And there is a series of deep learning mathematical operations going on there. This could be TensorFlow, PyTorch, FastAI, etc. Where it will be calculating a mathematical formulas which we call as convolutional neural network, which we study in image processing. And at end we have will get up probabilities where we can use this last part which I have annotated using TFLite in order to integrate it with mobile applications, embedded systems, and a web, what usually undergrad students use that to demo at their college during their examination. But yes, TFLite is one of the fast and very stable service which is provided by Google. Not only that, if we develop our solution using TensorFlow, we can migrate it to TensorFlow Lite. We have also due to the good contributors of AI, open source contributors, we can also convert the deep learning model, what our data has been studied and it can predict and give us the output, can be exported to TFLite. And we have an n number of projects on GitHub and also official guides on integrating TensorFlow Lite. So what is this TensorFlow Lite? Once we develop, say like we give thousands of images and we just want to detect whether that is a car or a truck, and we have 1,000 for each, and then we train it for say like 1 day, and at end of this phase we'll be having a model which will be easily around 200 to 300 MB. And just imagine, directly using that model and integrating with app is not possible because of the mathematical processing what the model carries, but also it will increase APK size, etc. A lot of burden on loading initially. So in order to reduce all this, TFLite comes into help, and we'll be using TFLite where the model would be somewhere around 10 to 15 MB or even less, and we can directly integrate it so that our app can now finally it can use the AI integration and it can do the task for us. So how now let us very briefly see how to generate AI models. So again we can classify into two, where we have our own data set and we have a very own requirement. In that case we have to do deep learning phase and the integration phase from scratch. where we have to study TensorFlow or PyTorch. We have to do data cleaning, data processing, and then we have to train model for like months, and then we'll be finally ready to integrate. Or else for general use case, right? For example, I showed a screen where it was able to detect a happy face or a sad face. That is already done. The model is available on the internet. So what we can do, we can uh, utilize the concept of transfer learning, where the model will be used as it is and we'll train it with our data. We won't be writing the model deep learning, we won't be writing any deep learning code. We'll be just loading our data in the prescribed size, whether if it is 200 by 200, 300 by 300, by annotating the data set, and within say 1 week we can have our model ready, which is trained on our data set. So, and this is a very overview flow on how do we do deep learning model generation using custom approach. So we have to gather the data, we have to annotate the data saying that this is car, this is bottle, etc. And then we have to select a framework, that is either TensorFlow or PyTorch, and then we train, we validate, because showing a picture of auto should not detect as a truck. So we have to validate with the exceptional cases as well, and then once we are ready to export, then we can completely use. And then also we have transfer learning procedure. It is as simple as that. We should have the data and we need to do the annotation. We will just select the model and then we'll train. The bottom process remains the same. So before we jump into TensorFlow, I would like to show you one use case where this is a Python. So here we have one model where I talked about transfer learning, right? So there's something very similarly it is happening here over here. We are importing the YOLO model. YOLO stand for you only look once, because the way this YOLO model has been generated is to only scan the pixel at once and quickly generate the output and move. So this is a very faster when it comes to our real-time use case. So we'll be getting data sets at multiple places. For example, RoboFlow, where it has open source data sets, for example, vehicles we have, persons we have, and also basic medical use cases as well. So we'll be loading the data set and we'll be defining we'll be just passing as an argument. We are telling to take 640 images in terms of 16 batches. So 640 images as a 16 batch, and then we have a Python code which is already written. We'll be just clicking on run and we'll be running, and at end we can visualize over here. For example, if you can see, these are the metrics, but if you can see here, it is able to detect the spoon, cake, baby, etc. So this is a transfer learning approach. So as a mobile developer, when we start learning deep learning, it is too much, because we have to understand, we have to go back to again our engineering mathematics syllabus. We have to read about calculus, everything, and then we have to actually learn Python and do. Once our use case is kind of very similar, that we have to detect something, first we can search on the Google. Thousands of models are available directly, and authors are they are publicizing it everywhere. There are Discord communities, especially for deep learning, for end user integrations, and we have Stack Overflow discussions where they are promoting, because AI researchers have their model, but now somebody has to use it. Without using it, it's waste. So here we are not generating again as an AI researcher, but we are consuming their model and we are training with their data. So this is with a bit of a hang of a deep learning. Okay, like I just want to try now. I don't want to do any Python shit. I just want to have a model. I have to feed it to my Flutter app and it should do my work. So there is something also called as teachable machine. So TensorFlow is very amazing. This was launched 3 years ago before lockdown at a TensorFlow roadshow at Bangalore, where Karthik Padmanabhan had showed a real-time demo. All we need to do is like on fly without zero code, no code, we can either do an image classification, or we can detect audio and we can work with it, or else we can also work with forces. For example, now we have a gym, right? like virtually it will track our postures, and with accurately it will calculate the sets, how many repetitions have been completed. If it is missed, warning. That is ForceNet. So let us click on image project, and here we can see standard image model. Let's select it, and now I have to give me a minute. This is zoomed out. Okay, now I have to just give, for example, let me say happy face over here and sad face over here, and we have two options already. If we have our data, right, either we can upload it directly or else we can click on webcam, and I need to just hold that button to record. For example, now done. So image frames have been collected, and now let us do for second one. Done. Let's hope it works. And here we have some additional parameters, how long we have to train, because the more we train, the more accurate the AI gets. It gets well trained, and also we can verify the learning rate. This learning rate is something at what phase this model should learn. If it is kind of learning something as a negative, this thing, how fast it should consider it as this is not the class, or if it is positive, how fast. So depending upon the learning rate, even though we have our model 99% accurate, it won't classify correctly because of the misuse of the learning rate. Because if you give 10, then just for 2 image it will just classify. It won't consider the thin line difference of the data. For example, we can have a blushing face or we can have a small smile. It won't consider. And I have to just click on train, and now it is training for 50 epochs. And now if you can see over here, my model is able to detect already. Okay, sad face is missing because of like bad expression I had, but whenever I'm giving a happy face expression, it is considering it as a positive this thing. And at last, like you just need to do, you have to click on a TensorFlow Lite, and you have to select a floating point or a quantized. You can download, and once this is downloaded, right, so you will get something as, you will get two models, two files. One is with the TFLite extension, what we wanted, and then second one is the label, because either if it is a face or a sad or etc. And now we are good to go, because we have seen an overview on how to kind of deal with this AI. Either do we have a no code solution, or how to do if it is a yes code solution. And I also, like, I have one particular use case what I had used for my final year project, where I used a custom approach, where I had to go to hospital. I have to kind of request for data. I got the data. I did annotate that manually and then build a model and then deploy it. So it is as simple as that. I've tried to, let's not go over to the code. It just again makes boring. So what I'm doing is I'm passing the image size, and I'm giving the directory where are the labels and the images, and also these are the CT scans what we get in hospital. So if our hand fractures, or if somebody is having something severe to brain, they scan CT, and at a point the machine is able to generate 256 to 1000 frames. That bulk it generates. So we are considering it as a volume, and we are composing the volumes, etc. We are doing the pre-processing, and then once we have the data processed so that our AI can learn, it will be in this stage, the image, and then we'll be training. And here you can see I have one model already, transfer learning, and that is called as unit. And with the learning rate, I have played around like 4-5 months, and then my model was ready. So this is regarding the AI phase. So quickly, I would like to stop here, and I would like to ask, like, if you guys have any doubt before we start with Flutter demo. Cool then. So now let us come to our Flutter integration, most awaited part. So in order to, there was one more package 1 year ago, it was just TFLite, that was very easy than the package what I have used here, TensorFlow TFLite underscore Flutter, because that had everything under the hood on the common use cases. For example, we need to just provide the image size, then it used to interpret, but in this we have more control on the developer, because we need to process the image according to the model what we generated, and then we need to kind of use the helper packages, and then we need to see. So it's very simple. We need 4 packages. For real time we need a camera plugin, then we need a TFLite plugins and image package, and here we as how we declare our images in our assets, as simple, we need to just add our folder. So if you want to organize it, we can create a subfolder and have it as model 1, model 2. If not, then we can just add it over here, and once we run pub get, we are good to go. So now coming to our main dot, I have declared the camera view, and we need to show that where exactly that is detecting. For example, if I am here and if it is showing Akshay is there, that is completely waste. That is a dumb use case of AI, right? So we need to exactly kind of show me here is the Akshay. So that's why we have a camera view, and exactly we need to overlap on the real-time images. That's why like we have stack widget. It displays the images. You know, it is a custom paint rectangle boxes. We draw it in order to it overlaps on the camera view, and at bottom we have some you know, we have metrics just for our cross confirmation. So this is all about the main dot, and let us now come to the main 2 parts where I just showed you, right? I showed you about now I talked about where does the TensorFlow acts as a hero and where does TFLite comes into picture. We need to just handle the input part and the output part. Like we, each model, as it uses matrices, it is very strict mathematical calculations. If we define that as we'll be passing image with 200 by 200 height width, then it should be 200 by 200. Even though if it is big as like 1000 by 1000, we need to chop it down, and we need to provide, or else our model fails, and there is a high chance that our model breaks, so that our whole pipeline, if it is not handled properly, the application will be down. So we'll just quickly see how are we handling the images. So we have our we have image utility class, where we are using all the necessary conversions at one place. If you are getting a camera image, how to pass it to RGB format, and if you are getting it as you know, RGB format, and how do we transfer back it to the camera image, how Flutter is able to understand. So we need to kind of write a helper bridge where our Flutter code, that code needs to understand that after we get the result, how are we able to process that and display to the end user. So we have this, and also we can save the images at our app directory if we click on save. So we can do all this. So this is about our image utils. So for example, here we get a camera image, that is the frames what we get in a camera, and then we are converting it to a required format as BGRA, that is RGB format, and then we will be passing the same value back. So then we have a classifier, a very important place we should have. So for example, now we know that we have input and we want output. So we want some mediator to talk between our Flutter app to the TensorFlow Lite, which will be kind of natively handled and will be getting result to our Flutter app. So we have an interpreter, as same as when tourists visit us, right? So tourists don't, 2 minutes, I'll wrap up. So tourists won't be knowing English, and we need an interpreter to interpret back from German to English and English to German. The same way the interpreter goes, we declare it, and we need to declare the model file and the label where we will be reading it. And carefully watch over here. I have passed as image size as 300. And then also we have something called as threshold. What is this threshold? This is something, once we have the probabilities back, if it is less than probability of not sure 50%, we are discarding it. Only if we are considering the probabilities of detection which is above 50%. And then we then we need to first load our model, which we have exported with a TensorFlow Lite, and then we need to also define in a tensors. This tensors is a multi-dimensional array which is very powerful than NumPy. So which is specially used to compute at a very fast speed at TPU and GPUs. And we'll be loading the labels, and we'll talk about predict at we'll talk about the prediction part, mean inference part. So it's as simple as that. We are keeping a check of start time when the inference is happening. Then we are taking the input image from the camera. Then we are processing the input image, and then we are getting the output buffer such as the location, what's the classes, what's the output scores, and the number of locations. And then we have a helper class, a small snippets which is acting as a bridge to take the input and then process it each step by step so that we can have a bounding box. And then we have for a demo where we are declaring the recognitions and we are printing it over here. Let me show the demo. Okay. So I just need to hot restart. It was locked. And now you can see the output over here. So we just provided a image, and this was already built model. We integrated it. We just passed the image. We took the output locations and the probabilities, and we are able to print back. For example, this is able to detect as a person over there and a laptop, keyboard very precisely. As a Flutter developer, without worrying much about TensorFlow or the deep learning, we were able to accomplish the use cases. And also, if you can see here, we are getting the recognitions with the labels, with the locations, such as from left, what's the position we have to place the bounding boxes. So this is about the TensorFlow Lite integration with Flutter. We have millions of apps already which is live on Play Store, and also recently in our Flutter Forward we had a sandbox demo where based on our face emotion which I just showed, Dash and Sparky used to react. If we are crying, it used to cry, or if we are smiling, it used to be happy. So this is a use case about the TensorFlow Lite with Flutter. And to conclude, it was too much. I did rush bit at end. Sorry on that. So to conclude, I would like to share our resources. If you are a deep learning enthusiast, if you want to understand how TensorFlow works, you can definitely take that course. It is very well explained, and we have teachable machine which I just showed to have your model without no code solution. And then the main package which you got to go home and test is play around with the TensorFlow Lite is TFLite_Flutter. So I would like to conclude where we talk, we meet, we'll be in a josh, but when we go back home, everything goes, because we need to practice in order to get closer to a perfection, or in order to actually understand the way it is implemented. So thank you once again for coming on Saturday weekend, and thank you GeekyAnts Flutter Bangalore for providing me an opportunity. Nice catching up with you all. Thank you.